There is a place in the universe where the laws of physics as we know them simply stop working. No light escapes from it, no signal, no sound, not even time behaves the way it should. And yet, these places are not rare. They are scattered throughout the cosmos, some of them billions of times more massive than our sun, sitting quietly at the heart of nearly every galaxy, including our own. Tonight, we're going to explore black holes, not the violent, dramatic versions you might have seen in movies, but the real ones, which, it turns out, are far stranger and far more beautiful. Let's begin at the very edge. Surrounding every black hole is an invisible boundary called the event horizon. It's not a surface you could touch or see. It's simply the point of no return, the last place from which, in theory, anything could still escape. Cross that threshold and the rules change. Time, which you experience as a steady, reliable flow, begins to slow. From the outside, an observer watching you fall in would see you appear to freeze at the edge, your image growing dimmer and redder until it fades away entirely. From your perspective, you might not even notice the moment you crossed. You would simply continue falling, further and further into the dark. Black holes are born from death. When a massive star, one much larger than our sun, exhausts its fuel, it can no longer hold itself up against its own gravity. In a fraction of a second, the core collapses. The outer layers of the star bounce off this collapsing core and explode outward in one of the most energetic events in the universe, a supernova. What remains is a region of space so dense, so tightly compressed, that nothing, not even light traveling at 300,000 kilometers per second, can pull free from its gravitational grip. This is what we call a black hole. But here's something that might surprise you. Black holes aren't really holes. They're objects. Incredibly dense, compact objects, but objects nonetheless. They have mass, they have gravity. In some cases, they spin. If our sun were somehow replaced by a black hole of equal mass, Earth would not be pulled in. We would simply continue orbiting the same way we always have, around a dark and lightless point in space. The difference would not be gravity. The difference would be the absence of light, and warmth, and life. There are different kinds of black holes. Stellar black holes form from collapsing stars and are typically between 5 and a few tens of times the mass of our sun. They are relatively small, some only a few kilometers across, and there may be millions of them scattered throughout our galaxy alone. Then there are the supermassive black holes. These are the giants at the center of galaxies. The one at the center of the Milky Way, called Sagittarius A*, is about 4 million times the mass of our sun, and that is not even particularly large by cosmic standards. In 2019, scientists captured the first ever image of a black hole, a supermassive one at the center of a galaxy called M87, 55 million light-years away. The image showed a glowing ring of superheated gas, and at its center, a dark shadow. That shadow was the event horizon. That was the edge of the unknown. And yet, even black holes are not permanent. In the 1970s, physicist Stephen Hawking proposed something remarkable. Through a combination of quantum mechanics and general relativity, he showed that black holes should very slowly radiate energy, particle by particle, over unimaginable stretches of time. A black hole loses mass. It evaporates. For a stellar black hole, this process would take longer than the current age of the universe many times over. For a supermassive black hole, the timescale is almost beyond comprehension. But eventually, in some deep and distant future, even the largest black holes will fade. The last trace of energy will drift away into the cooling universe, and what was once the densest, most gravitationally powerful object in existence will simply be gone. There is something quietly humbling about that. The universe contains forces of almost incomprehensible scale, objects that can bend space, halt light, slow time itself, and even those objects are temporary. Even the black holes will someday dissolve into the dark. Everything changes. Everything, eventually, passes.